Okay, last question. We are told, in an investigation of environmental causes of disease, data were collected on the annual mortality rate, and this was deaths per 100,000 men for males in 61 large towns in England and Wales. In addition, the water hardness was recorded as the calcium concentration in ppm in the drinking water. Dataset also notes for each town whether it was north or south of Derby, England. Alright, data are found in a file called Hardwater, and that's from chapter 21, and you're going to find that on D2L. Alright, we're asked, is there any significant difference in mortality rates in the two regions? Okay, the regions are broken up as being either north or south of Derby, and a question is about mortality rates. Alright, now, mortality rates, and what else are we told here? They're also telling us that in this file, there's information in here on water hardness, but the water hardness has nothing to do with question A. We're simply being asked, is there a difference in mortality rates? Okay, test the appropriate hypothesis, and check assumptions and get a confidence interval, and then we're asked what information does the confidence interval give you that the test of hypothesis does not. Alright, we are comparing mortality rates, but when I go into the data set, let's go have a look, because usually the word rate would suggest to me that it's a proportion. But when I look at my data, I've got mortality, so that's the number of deaths of males per 100,000. And I could go in and divide all these numbers by 100,000, but I don't really need to do that. This is the mortality. I understand that this is the number per 100,000. And in another column, it tells me whether these numbers were from south or north of Derby. And I'm also told calcium concentration, which, by the way, gives you some indication of water hardness, but the question does not mention anything about water hardness, other than to say that water hardness was recorded. Okay, now, going back here, I have mortality, and mortality is a count, and I got a whole bunch of different ones. And we're asked, is there a significant difference in mortality rate? But because we got more than one, really what this question implies is there a difference in the average mortality rate in the two regions? Alright, if I'm going to compare averages, then this means I have again a choice between a two-sample t-test or a paired t-test, because I'm comparing population means. So the question I have to ask myself is, of these 61 large towns in England and Wales, alright, of these 61, they were either north or south of Derby. Now, a town north of Derby, does that have any connection with a town that's south of Derby? Not really. I mean, you know, the fact is, we find where Derby lies on the map, and we determine, probably from the latitude, whether that town was north or south of the town of Derby. And whatever towns I have north of Derby really don't have anything to do with those that were south of Derby. We haven't deliberately paired anything up. So I would presume from this that we're looking at independent sampling, and this is going to be a two-sample t situation. Alright, what's my null hypothesis? Okay, it doesn't matter how you set this up, whether it's north or south, because it just asks us, is there a difference? Now that means I can do north minus south, or I can do south minus north. It doesn't matter. Anyway, I'm going to do north minus south. So mean of north minus mean of south. Alright, let's get that done. And my null hypothesis is that there's no difference versus that there is a difference, but It's not asking me to prove whether north is higher than south or south is higher than north. So equal to versus not equal to. And what do we got? We got an alpha of 0.01. Oh, something different this time. Okay, so it's a two-sample t. I am not going to bother with doing the calculation. We're just going to go into Minitab and we're going to run the test. Okay, we've decided it's going to be a two-sample t. So under stat basic statistics, two-sample t. Now note the way that your data are in here because they're in here a little bit different than what we've seen before. All of our data are in column C1. So that's both of my samples are in one column. And the other thing would be each sample is in its own column. Well, each sample is not in its own column. If it was, I'd have to have a mortality for south of Derby and another column for mortality of north of Derby. So it's this first option, which is generally the way Minitab likes to have things set up. So all the data I'm interested in are in the file called mortality, and I'm going to take those numbers and I'm going to break them up by Derby. Okay, now, problem about this, of course, is I don't know what Minitab's going to do. Is it going to do north minus south or south minus north? I think it goes alphabetical, so it's going to do north minus south. I go to options. I want to know is the difference equal to 0 versus whether it's, yeah, right, not equal to 0. And I'm going to run the test two ways. The first way I'm going to assume I don't have equal variance. I don't have a clue if I do or not. And I need to get box plots. Alright, the south data looks pretty normal. The north data got an outlier. Chances are it's not going to be normal, but we'll come to that. The other thing, too, that we want to look at is whether the spread in these box plots is approximately equal. Now, the south is a little bit longer than the north. I don't know if that's going to make much of a difference. The overall spread from min to max, though, like the overall range, is probably about the same for these two. So we might be able to assume equal variance. So here's the test done without assuming equal variance. And I'm going to go back in and do this again. And this is the one in your notes is referred to as the pooled test. And this time I'm going to assume equal variance. Say OK. There's my box plots again, so that doesn't change. Now, I'm just going to copy and paste both of these into my Word file, and then we're going to talk about it. Okay, hang on now. So, what have I got here? I'm testing that the difference is equal to 0 versus it's not equal to 0. Now, looking at the numbers, by the way, we got 34 towns north of Derby and 27 south of Derby. The averages are 1,600 and roughly 1,400, so there may be a significant difference here. Alright, Minitab has, thankfully, set this up as north minus south. It has gone alphabetical. And it tells me that it did equal to 0 versus not equal to 0. Get rid of that bit of piece. And let's see, my test statistic is 6.47 with a p-value of 0 and degrees of freedom of 5.3. So this one here is using unequal variance. And here's roughly the same information. Notice this time it says it used the pooled standard deviation. So this is the pooled test. Now, do I have very many differences here? I got a test statistic of 6.47 versus 6.53, pretty much the same. No difference in the p-values, a little bit of difference in the degrees of freedom. Alright, both tests are essentially telling me the same thing. And of course, what is it that I want to know? Is my p-value less than my level of alpha, which in this case is 0.01. Well, whatever these p-values are, and they've been rounded off to 3 places after the decimal, they're at most 0.0003, which is definitely smaller than 0.01. So here, yes, in which case we reject the null statement. Now, if we're going to reject the null statement, we are really saying that yes, there is a difference in the mortality rate. There is a difference in mortality rate for these two areas. Alright, now, and actually these are the mortality numbers. I guess if I'm going to talk about rates, I should have divided them by 100,000, but it's not going to make any difference because the stats are going to work out to be the same. Alright, there is a difference in mortality rates. Okay, so we've decided there's a difference in mortality rates, and we have to check assumptions. Have they been met? And if not, what effect might they have on your test? Well, alright, well, for one thing, we're assuming these towns were picked randomly and independently north and south of Derby. And the other thing is that both sets of data have to be normal. So that's the question. And we already saw a box plot. Hold on one second. My box plot, my south data look pretty normal, but my north don't really. So if I go back into Minitab, okay, I've got that. Alright, now here we got to do a little bit of fancy footwork. Oh, and by the way, I went back in and did this based on rate. I took mortality and divided it by 100,000. You get exactly the same statistics. I just wanted to double check that, but you do. Alright, now I want to look at the north of Derby, but my data are all in one column right here. So in order to handle this kind of stuff, you need to unstack your data, and I'm unstacking the mortality numbers using the subscripts that are in the column that says Derby. Alright, Minitab wants to know where do you want to put it. I'm just saying put it in the after last column in use. So here's my mortality numbers north and south. And we're going to check both of these using Ryan Joyner. So what have I got? My north data using Ryan Joyner. Ryan Joyner says north is normal. My p-value is greater than 0.1. And if I go in and check the south data, Minitab says, survey says, p-value greater than 0.1, so that's also normal. Alright, so have I met my assumptions? Yes, I have. Now, the other question, last thing, is we were asked to get a 99% confidence interval for the difference in mortality rates. What information does it give you that the test of hypothesis does not? Well, alright. Well, I got an interval there, but it's not at a 99, so now I got to go back into Minitab. Let's hold the phone. Stat, basic statistics, a 2-sample T, and I'm doing, yeah, I checked mortality rate. Hang on now, just so we're all on the same page. Mortality versus north or south of Derby. Go to options, and I'm changing this so that it reflects a 99% level of confidence. And I can assume equal variance or not. I don't think it's going to make any difference here. Yeah, I got those plots again. And here's the interval. Okay, now what does this interval really tell me? Let me get it up down here. Alright, so, and that difference was, we did north minus south. That's important. Keep track of that. Alright, so it's telling me that we're 99% confident that the true difference in the number of mortalities between north and south of Derby falls between roughly 144 to 342. So really, what is that telling me? It's telling me that there's more mortalities north of Derby than there is south of Derby. All the numbers in this interval are positive, and the only way I can get a positive interval is if the average of the north is higher than the average of the south. And this gives me an idea of where is the true difference. So for people in the north, there's between 144 to, if I round this off, to 341 more deaths north of Derby than south of Derby. So whatever's going on in the water, which is another analysis that we're not covering right here, we might want to see whether water hardness has any effect, but that's not for this assignment. Okay, I think we're done here.